Hey everybody, this is Mr. Munson. We're in Unit 9, Logic and Reasoning, and we're going to be dealing with concept number 4, writing a proof, like a two-column proof. And we've done this in the past. I've been setting you up for this section, so it's not too much of a stretch for you. Let's get started. Okay, so let's look at this problem here. Now, before I start writing a two-column proof, I'm just going to show you that you've been doing a lot of the mechanics that we're going to use, kind of logically showing steps and things like that. But for some of you, you skip steps, and that's going to cause you a little bit of concern. We're going to have to show each step. Here is an algebraic equation, and we're going to prove that x is equal to 3 if the original statement is true, and it is. So I'm saying, hey, given this statement, the 3 times the quantity 4x plus 5 and so on, I want to prove that x is equal to 3. So before we get into two-column proofs, let's just do this like our normal everyday way. Okay, so what we're going to do is just solve this. Now for me, the first thing I would do is I would send this 3 through. You know, I would do the distributive property. Okay, so now I moved this down to the distributive property to show why I can write this statement, right? This statement right here is the result of distributing through. Now, as we do these kind of problems, be it geometric, we're looking at figures and proving triangles are congruent and so on, or algebraic like this, we always do one step at a time. Okay, next step. All right, and I'm going to add the word property to this thing over here, right? Distributive property. Now, by using the subtraction property, I'm coming up with this 10x plus 15 equals 45. Next step. Now back in algebra, and in this year I've been saying to you over and over and over, show your steps, draw your lines, all those things. And that's basically not only for organization, but to prepare you for this unit, right? We show one step at a time. So again, I use the subtraction property to come up with 10x minus 30. Next step. All right, and I get x equals 3. Now I'm not writing in what the reason is I'm allowed to get to this step, x equals 3. I want you to just write it in, just like we've done subtraction property, and so on. I want you to go ahead and write in what you think I'm going to write here in this spot. And I hope you wrote division property. Pretty simple stuff. Okay, now as I started off, I brought this down from the problem and put it here. Now what I want you to know is the reason I'm even allowed to write that as being true is because it's given to be true. Okay, as you look up here, it's given to be true. That's usually the very first step of any good proof is that you bring in a piece of the given information. Now I'm just going to go through this same exact problem, but this time as a two-column proof. Now this is a formal two-column proof of what we just did, kind of informally, the way we've been doing it in the past. And I'm not in any means suggesting that you're going to start writing your equations and writing it in a two-column proof. I'm using this world that you've been working in, algebra, for a long time. We're going to use this world to kind of help you understand how to write geometric proofs. That is, show like triangles are congruent and things like that. Okay, so just stay with me on this. Go ahead and set up your problem. I write the ones on both sides, and I'm going to write my statement. So I'm going to bring in my statement there. So I bring in my statement that's given, and that starts my two-column proof. Next step. Line 2. There you have it. Go ahead and set up for the line 3. All right, so if you're taking notice, I'm not showing my steps. I'm just showing the final simplified version of each step, okay? I don't have the minus 2x from each side. But what I do is I write my reason, subtraction property on this side, and in parentheses I write what I did. I subtracted 2x from both sides. All right, I'm going to encourage you now to go ahead and write the rest of this proof. We just have a couple more steps to go. I'm going to pause and come back and check to see how you did. All right, and there you have it. Now notice the last statement of my proof, x equals 3, matches exactly what I have here. I don't have 3 equals x, I have x equals 3. Okay, now I set up my proof so that my x's end up on the left-hand side, and that's great. Sometimes that doesn't happen, and so we have to flip it in our proof. You'll see that sometimes happening, and just ask me how to do that logically in a proof, how to flip it in your proof, okay? All right, very good. So there we have it. Let's go on to another one. All right, now let's take a look at this one. Now this one has a series of statements over here that we can borrow. Okay, they're given to us. And so what we're going to do is we're going to look at this proof, come up with an idea, and kind of make sure that we would have it. So kind of one of the first things you do is you take a look at what it is that you know, right? Here's the given information. So what I like to do is I like to take that given information and put it into the drawing. As you can see, the drawing already has it. Sometimes that's not the case, so we'd put it into the drawing. The given information here tells us that those opposite sides are congruent. Now, what they want us to do is, and they're also describing that AC is a diagonal of this thing. Well, let's take a look at what they're asking us to prove. They're trying to ask us to prove that triangles are congruent. Let's just pause here for a second. How do we prove triangles are congruent? Now, we did this in Unit 5. Now, what I want you to do is I want this to be part of a review here as we get towards the SOL. And so what I want you to do is I want you to do one of two things. I want you to go back to your student learning map for Unit 5 in your notebook and look to see which concept area that we dealt with proving triangles are congruent. And look over the vocabulary words and you'll see what the clues are that you need to do. Okay. The second thing is that you just simply list the ways we can prove triangles are congruent. Okay. So if you can do that without looking back, fantastic. Go ahead and put me on pause and see if you can write them down. All right, and there's 4 of them. I'm still missing one. And we know it's not this one. Okay. It's the 2-letter one. The one that you can use if you have a right triangle. There it is. Okay, so hopefully you got those right. Now there was 5 ways that we prove triangles congruent. Those are short ways. There's really a 6th way that you prove all the sides or have a corresponding side that's congruent, and all the angles have a corresponding angle that's congruent. Okay, we're not going to do that way. That's too hard. All right, let's get back to our proof. So to prove these 2 triangles are congruent, I'm going to need to know some more information. And so what I look at this is I would like to know some angles, so I could use angle side or something like that. Or if I could get one more side, then I have a side. So kind of the third step is our strategy. You know, we look to see what we need and then come up with our strategy. Okay, I'm going to go for that scenario, and this is going to be a side scenario. Okay, so let's take a look. We form this kind of proof. Now this is actually from a released SOL in the past. So it's kind of a hybrid of the 2-column proof. So as you can see in the very first line here, they put that AB is congruent to DC. Okay, so they said AB is congruent to DC. And in the same line, they wrote BC is congruent to AD. Okay, and they can say that's true because it's given, right? It was up here as the given information. Next, they say AC is congruent to AC. This segment right here is congruent to itself. Now, what I want you to do is look through this series of words, phrases, and find out what do you think belongs for the reasoning. Put me on pause, come back and check your work. Did you get it right? Isn't that cool? That's easy, right? And that's because we've done that work in the past. That makes this section a lot easier. Now we have 3 sides that are congruent. So now we should be able to say the triangles are congruent. Now again, I want you to look through this series of words and phrases and decide which one belongs there for the reason that the triangles are congruent. Put me on pause, come back and check your work. And there you have it, the side theorem, right? Okay? All right. Simple stuff. Let's go on to another one. All right, so just take a look at this one. Don't write this down, okay? That'll save you some time. We're going to write it down in just a bit, but don't write this down. So let's start with what we know. Now we know that angle A and angle D are given as 34 and 34. Next one, CA and CD are equal to each other. So we go ahead and mark that, okay? So now we know that just from the definition of congruent angles, if their measures are the same, then they're congruent. Okay. Now remember, to prove triangles are congruent, which is what we're going to eventually get to, we need to show pieces are congruent to each other. Right now we just know their measures, but I can go to the idea of if their measures are the same, then they're congruent. That's no big deal. All right, and so now we're looking to prove that these triangles are congruent. Next step. What do we need? Well, we need to know some other angle or some other side to prove that the triangles are congruent, so we can use one of our shortcuts. And the easiest thing is that these two angles are congruent. And we're going to know that from vertical angles. So that will be easy enough to put in our proof. We'll just simply say that angle is congruent to that one by vertical angles. Cool. All right, so our strategy is going to be to bring in our given information, bring in that these vertical angles are congruent, and then state that triangles are congruent by angle, side, angle. All right, let's write our two-column proof. Now, as I go through this, I want you to know that you feel free to kind of work ahead, and you might make mistakes. No problem. Do it in pencil and erase it, right? But the more you think about it, the easier to get. That will be the difference between you and the other people, okay? So let's go ahead and get started with this proof. Let's bring that in, okay? Let's bring in that those two angles are congruent. I'm going to go ahead and mark those as being, or not being congruent, but being 34 degrees. Now, if you don't mind, my marker's a little thick, and to get 34 into that little tiny angle there is going to be a little bit hard. So I'm just going to leave it as assumed, okay? All right, now as I do this, I want you to know there's going to be things like, oh, I would have never thought of that or whatever, and that's cool. That's what you're going to experience as you're watching me do proofs, so that you have this, watching me do it so that you can do it on your own, okay? Now, to prove triangles are congruent, we need to show corresponding parts are congruent, okay? Right now we don't have anything that's congruent. We simply have angle A is equal to 34 and angle D is equal to 34. But now I can say they're congruent. And the reason is, it's the definition of congruent angles. If you look back when we had the definition of congruent angles at very early on at the beginning of the year, we simply said, hey, if two angles have the same measure, then they're congruent. And there's our logic conditional statements we've had in the past. Now go ahead and draw an A over here, because I just proved a pair of angles are congruent. Line 3, CA is equal to CD. Now, again, I need to show that pieces are congruent. See if you can write line 4 on your own. All right, there you have it. We have two segments that are congruent, and that's by definition of segments being congruent, definition of congruent segments. Let's put an S, and we're just going to simply spell out angle, side, angle. All right, so now I have angle DCE is congruent to DCA, okay? So let me kind of go back, and I apologize. I'm going to go back and mark some things. I've got these angles being congruent, and that's good. And then I have these two angles congruent, or these two segments congruent, so we'll mark those. And then we have, finally, these two angles congruent by vertical angles. And so let's add to that I've just showed on this line, a pair of angles that were congruent. So if you look at that, I have spelled angle, side, angle. And so with that, I can go ahead and say my triangles are congruent. And so my last line is, of course, what I'm trying to prove, and that is I've done it. The triangles are congruent, and I state the reason why, angle, side, angle. Okay, go ahead and draw your line and write a summary. And then basically, if you look at what we've done two-column proofs. The proofs that I've given you here are going to help you model and do the problems for your do-it problems. Now remember, when you get done with your do-it problems and you bring them into class, we're going to talk about them, make sure you got them right, and then you have a real quick quiz on those do-it problems just like that. So make sure you understand them completely. The proofs that I chose here in the video are pretty simple, and I know that when I say that, I mean they're basic. You might not have understood completely how to do it on your own, but the more experience you have with them, the better you'll get at them. Here's your do-it problems. I'll zoom in so you can see them a little bit better. There you have it. Several of those problems are review problems. Please have those ready to go. Understand completely how to do those when you come in next class. Take care.